Welcome to The Explainer, where we break down big topics into bite-sized pieces. Today, we're jumping into the fundamentals of one of the most popular programming languages on the entire planet, Java.
Now, to help us out, we're drawing insights from this fantastic guide, Java in Short, by AI.Baki. It's going to help us get right to the heart of what makes Java tick.
I mean, think about it. From the games on your phone to massive software that powers businesses, a whole lot of them start with Java. And today, we're going to see exactly how that happens. We're going to kick things off the same way almost every programmer in history has, by writing a program that just says a simple hello. It's more than a tradition, it's the perfect way to see the basic skeleton of the language.
Okay, I know what you're thinking. This looks like a jumble of strange words and curly brackets. But trust me, it's not nearly as complicated as it looks. Every single piece you see here has a specific job, and we're about to figure it all out together.
So here's the breakdown. That first line, public class hello world, just think of it as the main folder for our whole program. Inside that, you have main. That's the front door. It's the exact place the computer starts reading the instructions. And that last line, systemout.println, well, that's the actual command telling the computer, hey, print this message.
And just like that, you get it. The core idea is way more straightforward than it first appears. It's all about giving the computer a list of very specific logical steps to follow.
All right, so we've seen a full Java sentence. Now let's break it down and look at the words it's made from. Just like English has nouns, programming languages have data.
So in any program, you need to store information, right? Like a user's name or a score in a game. We do that with variables. You can literally picture them as little labeled boxes inside the computer's memory, where you can stash a piece of information.
Now, those labels on the boxes are super important. They're called data types, and they tell Java what kind of information a variable is allowed to hold. This is how the program knows the difference between, say, the number 32 and the letter A.
So once you have your words, your data, you need to combine them to make sentences that can actually make decisions. This is where your code starts to feel like it's, well, thinking. And to do that, you use operators. Think of them as the action words, the verbs, in your program and sentences. They're what lets you do the math, make comparisons, and connect different ideas.
And this shows the difference perfectly. On the left, you've got your arithmetic operators doing math, addition, subtraction, the usual stuff. But over on the right, those are comparison operators. They're not calculating a result, they're asking a question, like, is this bigger than that? And the answer can only ever be true or false. This is what we call control flow. It's how you use those true or false answers to make decisions. It's just like in real life. If it's raining, then I'll take an umbrella. Otherwise, I'll wear sunglasses. This code is doing the same thing. If the number is positive, do one thing. If not, do something else.
So far, our code is pretty simple. But what happens when you're trying to build something huge like a modern video game? Just having a long list of commands would turn into a tangled mess real quick. To fix this, programmers use a really powerful idea for staying organized.
And that idea is called object-oriented programming, or OOP for short. The whole point is to stop thinking about code as just a list of instructions and start modeling it after things in the real world. So instead of having a variable for car color here and car speed way over there, you just create a single car object that keeps all its information and behaviors in one neat package.
To really get this, let's try an analogy. The key idea in OOP is the class. And the trick is to think of a class not as the thing itself, but as the plan for the thing. A class is like an architect's blueprint for a house. The blueprint itself isn't a house, right? It just defines what a house has, how many rooms, where the doors are. An object is the actual physical house that you build from that blueprint. And from that one single plan, you can build tons of unique houses.
So let's bring it back to code. A car class is our blueprint. It defines the attributes, or the data, that all cars have, like a make, model, and year. It also defines the methods, or the behaviors, the things a car can do, like start, drive, or stop. Then we can create individual car objects from that blueprint, a red sports car, a blue sedan. Each is unique, but they're all built from the same fundamental car plan.
So there you have it. Variables, logic, and objects. Those are the fundamentals, but they open the door to a massive world of possibilities. Let's just take a quick peek at what you might learn next.
What happens if your program tries to divide a number by 0 or can't find a file it's looking for? Without a plan, it would just crash. So you'll learn about exception handling, which is basically building a safety net to catch those errors and deal with them gracefully so your app keeps running.
You'll also learn how to read and write files. This is so important for any app that needs to remember things. Think about a video game saving your progress, or a word processor saving your document. All of that happens by interacting with the computer's file system.
And eventually, once you're comfortable with the basics, you can start building the things that users can actually see and click on. You can use special toolkits to create graphical user interfaces, the windows, the buttons, the menus that make up the apps you use every single day.
So from a simple hello world all the way up to the idea of a digital car, you've now seen the foundational map of the Java language. We hope this has sparked your curiosity to go out and continue the journey on your own.